presenting anomaly detection using machine learning. The presentation will be done by me, Siddharth Shankar, and my partner Himanshi Tyagi.
What is anomaly detection? Anomaly detection is a technique of identifying rare events on observation which can raise suspicions by being statistically different from the rest of the observation. Whenever we talk about anomaly detection, it means detecting the outliers. For example, your bank account is over here and you are probably present in India right now. If someone tries to use your user ID or your password or your phone number from a very different location, then suddenly you get a message from the bank saying someone is trying to log in into your account. Not only that, your Gmail account or any other social media. So, how does it work? Simple statistic techniques such as mean, median, and quantiles can be used to detect unvariate anomaly features values in the dataset. Various data visualization and exploratory data analysis techniques can also be used to detect anomalies. Using various supervised and unsupervised machine learning algorithms such as isolation, forest, local outliers, robust covariance, one class support vector machine, etc. Types of anomalies are point anomaly, contextual anomaly, collective anomaly. Tuple in a dataset is said to be a point anomaly. An observation is contextual anomaly. A set of data instance helps in finding an anomaly is collective anomaly. Supervised anomaly detection. This method requires a labeled dataset containing both anomalies, normal and sample, to construct a predictive model to classify future data points. The most commonly used algorithm for this purpose are supervised neural network, support vector machine learning, and k-nearest classifier. The pros of this anomaly detection is this technique provides the ML system with clear example of standard data points. Cons, it requires a time-consuming manual tagging process. Unsupervised anomaly detection. Our data scientists and ML engineers provide the algorithm with unlabeled dataset and let it discover pattern or anomaly on its own. This method does require any training data and instead assume two things about the data. That is, only a small percentage of data is anomalous and any anomaly is statistically different from the normal samples. Based on the above assumptions, the data is then clustered using the similarity measure and the data points which are far off from the cluster are considered to be anomalies. The pros are this approach is more suitable for investigating unprecedented scenarios, including new types of cyber attacks for which data has not been labeled before. The cons are it requires massive datasets and computing power. It is generally associated with deep learning, an advanced branch of ML relying on artificial neural networks. Semi supervised anomaly detection. This approach combines the previous anomaly detection techniques to maximize their pros. Data engineers provide an algorithm with a small amount of labeled data to partially train it, then use the same algorithm to label a larger dataset autonomously. Based on the above assumptions, the data is then clustered using the similarity measure, and the data points which are far off from the cluster are considered to be anomalies. The pros are thanks to pseudo labeling, the tagging procedure is faster and cheaper than supervised learning. The cons are the process to complement the initial set requires several iterations.
Thank you, Himanshi, for giving us a brief introduction about the anomaly detection. Now we will try and understand anomaly detection using KNN, which is the K nearest neighbor algorithm. So basically, what we are doing here is first we are generating a random data set with two features in it. And then, as Himanshi mentioned, the outliers, we set a percentage for it. The percentage that we have used is 0.1. Next, we'll separate the two features. And now this is basically the visual representation of the data set without any of the outliers mentioned or separation of the outliers. And then we'll train a classifier, which is KNN in this case, and we'll print the predicted scores. In this picture, as we can see that these are the basic decision boundary, and this dot mentioned here, the red dot, is the outlier. This is basically just this code is setting the threshold values and basically coloring a graph. And in the end, the result is this. As we can clearly see here, the inliers are the one that we require, and all the other black dots are the true outliers. Now we'll discuss the advantages of machine learning for anomaly detection. ML-powered anomaly detection systems offer several advantages over traditional solutions. Traditional methods rely on rules that should be manually updated, which uses a lot of manpower. But when we use ML algorithms, it autonomously learns from the new data sets they process, ensuring higher reactivity to new anomalies. The same high dimensional data that may be a burden for traditional anomaly detection methods represent a valuable training resource for machine learning algorithms. While rule-based methods may have a hard time with unstructured data, for example, images, medical images or handwritten reports, ML systems can process any kind of data set thanks to ML fuel technologies like computer vision and natural language processing. ML based anomaly detection systems also consider a broader range of variables compared to rule based solutions, resulting in superior accuracy, a lower rate of false positives that require manual examination, and improved cost efficiency. Now we'll discuss some of the use cases of anomaly detection. The first one we can see is cybersecurity. It is usually guaranteed with the help of network behavior anomaly detection, also known as NBAD technology. The system analyzes packet signatures to detect security threats and block incoming or outgoing data that is compromised. NBAD also conducts continuous network monitoring. So it kind of works in real time, basically to detect suspicious events or trends. Uh, Another use case could be graph based anomaly detection. It is used to prevent fraud with credit cards, bank accounts, and insurance. ML systems also enable online banking fraud with the help of behavioral biometrics that also detects anomalies in consumer spending in real time. Another one of the use cases that we can see is in terms of industrial automation. Anomaly detection systems use data coming from numerous sensors to identify any malfunctions in the machinery, thus able to detect abnormalities early to prevent further damage uh, or manufacturing defects to the machinery that is being used. Discover how predictive maintenance plays a role in preventing such industrial damages. Anomaly detection can be also used to track health of computer systems by identifying deviations from the norm in system performance metrics. For a deeper dive into predictive system health monitoring, the ability of anomaly detection systems to compare and analyze images allows accurate fraud detection in banking and insurance. Anomaly detection algorithms deal quite well with big masses of unstructured data in the stock exchanges, be it regular stocks or cryptocurrencies. ML systems classify the available data about price movements. This information may be instrumental in trading decision making. It can also be used to improve the quality of data sets by identifying and removing outliers in the initial stages of a machine learning framework. Outliers are data points that stand out from the rest of the dataset as mentioned before. By removing outliers, anomaly detection can improve the accuracy of machine learning models. Thank you.
Yeah, improve पे क्या लटका है वो?
पता नहीं भाई, दिख थोड़ी ना रहा
बोला तो तूने भी गंदा ही था. How did it action?
है।